Okay, so today I will just give you a short proposal of what my PhD study will be about, and I will use GIS and spatial analysis to basically look at the spatial relationships and spatial patterns within pest monitoring data and the landscape around them. Okay, so just to give you a short introduction of what GIS is, basically it's a computer system which you can use to capture, store, query, integrate and analyze spatial data. And mostly many different types of data can be used or integrated into a GIS and represented as map layers, for instance, like in this picture. And when you do this, undetected trends and spatial patterns often emerge. And then spatial analysis is just a manipulation and transformation of this spatial data, where you get the opportunity to extract additional information from that data. Okay, so to just give you a background, integrated pest management is currently implemented in South Africa in the form of sterile insect technique and bait application technique. But integral to these technologies is to know where to apply them and for the effective use of them. But integral to that is basically to know where and when to apply these technologies, and also to understand the ecological relationships of the pests and the surrounding landscape. And then Vernon et al., to help us with this, Vernon et al. In 2006 highlighted that GIS and geostatistics are very good tools or powerful tools to be used in IPM programs to spatially and temporally analyze pest population dynamics and the relationships between the pests and the landscape around them. Okay, so the aim of my project is to use GIS and geostatistics to better understand the effect of biotic and abiotic factors on the distribution of polyphagous pest populations on an area-wide basis. Okay, so the objective is to establish a GIS and a relational database containing biotic and abiotic factor data of the study areas, as well as historic pest monitoring data. Then investigate the spatial patterns in the historic pest monitoring data, investigate the spatial relationships between the historic pest monitoring data and the attribute data, and the attribute data is now the biotic and abiotic factors, and then define spatial parameters under South African conditions to be used in future development of insect pest risk maps. All right, so the pest that I'll be looking at is Ceratatis capitata, or Mediterranean fruit fly, which is a major pest of fruit here in South Africa as well as worldwide. Codling moth, which is a key pome fruit pest, as well as false codling moth, which is a key pest in citrus here in South Africa, largely due to its international phytosanitary status. Okay, and then my study area will be across the Western Cape, and the red borders just indicate the municipal areas that I'll be working in. The towns in yellow are just there for reference purposes. Some of the data that I'll be using is long-term pest monitoring data for my target pests, crop distribution and phenology data, landscape feature data, climate data, as well as topographical data. Okay, so to fulfill my objectives, I'll do some extensive structured literature surveys. I'll do data mining of the monitoring data of the pests themselves, as well as the attribute data within the study areas. I'll use a combination of spatial analysis, using tools like spatial autocorrelation, hotspot analysis, and exploratory regression analysis. I know these are big words, so just afterwards you can just come and talk to me if you don't know what they are, but I don't have time to explain them all. And then I will critically assess the primary biotic and abiotic factors identified. So basically the outcomes, and this is an important part, the outcomes of this project is to establish a GIS to visualize and analyze available historic pest monitoring data, as well as the abiotic and biotic factors that are available, the data of that. Identify the primary biotic factors and abiotic factors that can be used to determine pest risk on an area-wide basis, and then identify spatial parameters for those factors that I've identified, the primary factors, for the future use in developing insect risk maps. And hopefully having this information, it will create a platform for Growers and Growers Association to better integrate into IPM and area-wide IPM. and also will hopefully refine the management recommendations for my target pests. So just to give you just a glimpse into the future of what the possibilities are of the outcomes of this project, and it lies in creating insect risk maps on an area-wide scale. So for instance, you'll have your spatial input parameters, which will be the outcomes of this project. And this will be things like maximum, minimum temperature, rainfall, humidity, host suitability, etc. And then you'll go on and further on and you'll build a simulation model which will give you a map looking something like that, where the red areas just indicates areas of risk in terms of pest population levels. And having this information of the pests of these risk maps, you can then later incorporate it into a spatial decision support system like this one developed by Cohen et al. In 2008 in Israel for Mediterranean fruit fly and citrus, where it basically just assists the decision maker in the decision to spray or not to spray. So yeah, thank you very much for your attention.